Hello students, welcome to your physics class. So this is your first lecture on a very important topic. The module that I am going to start today is classical mechanics. And the particular topic in classical mechanics that we are going to discuss is motion of a system of particles. Motion of a system of particles. Now, what do I mean by the term particles? When I say particles, what do I mean? When I say particle, I mean a body whose dimensions may be neglected when considering its motion. Which is why when we consider the motion of our Earth or any planet about the sun, then we may consider the planets or our Earth to be a particle in motion along a fixed trajectory around the sun. So this is important. Now some quick questions. First question, a particle is a body whose, you have 4 options. Please choose the correct one. Second question, the number of degrees of freedom or number of independent coordinates required to specify the position of a free particle in 3 dimensions is, please choose the correct option amongst the 4 options. Now, before I start my actual lecture, I would like to give you an outline of the topics I intend to cover through this lectures on classical mechanics. First, I want to introduce you to what are discrete and continuous systems. Next, for a continuous system, I want to discuss what is density. We want to understand together what is density of a continuous system. Then we would try to look into rigid and elastic bodies. What are rigid bodies and what are elastic bodies? Next, we would try to understand what do we mean by degrees of freedom of a system of particles. On what it depends that how many degrees of freedom a system of particles has. Then we would be addressing the very important issue of constrained motion or motion in the presence of constraining forces and how constraints affect the number of degrees of freedom of a system. Next, we would look into a very important constraining force, the constraining force which moving systems most often encounter, frictional force. Then we would be looking into classification of constraints into various categories as holonomic and non-holonomic constraints and as scleronomic and rheonomic constraints. So let's proceed. First, trying to understand what do we mean by discrete and continuous systems. When can a system of particles be considered to be discrete and when it has to be considered as a continuous system? For that, of course, the first question is, what is a particle? If you want to understand the nature of a system of particles, first we have to answer the question, what is a particle? And as I mentioned before, a particle is a body whose dimensions may be neglected in describing its motion. And the position of a particle is very important. The position of a particle in space is defined by its position vector. So here in this picture, we have shown what we mean by position vector of a particle. So here we have two particles, one with mass m1 and the other with mass m2. And the position vector of particle m1 in three-dimensional Cartesian coordinate system. We have three-dimensional Cartesian coordinate system, as we see, with three coordinate axes x, y, z. So in this 3D space, the position vector of particle m1 is r1, whereas position vector of particle m2 is r2. And as these position vectors are position vectors in three-dimensional Cartesian coordinates, thus in order to specify the position of a particle with the help of these position vectors, we need three Cartesian coordinates. So suppose to specify the position of particle m1, we would use the Cartesian coordinates x1, y1 and z1. And to specify the position of particle m2, we would require the three coordinates x2, y2 and z2. So to specify the position of one particle in three-dimensional space, we are requiring three independent coordinates. Similarly, when we have a system of capital N particles, if our system is constituted by capital N particles in space, then in order to specify the position of, say, the ith particle, we would require three coordinates, again xi, yi, zi. So in order to specify the position of n, capital N such particles, we would require 3n coordinates. To specify the position of one, 3 coordinates, and thus to specify the position of n particles, 3n coordinates. Now, this is our system of particles. Now, a system of particles can be discrete or it can be continuous. A system of particles is said to be discrete when the individual particles form separate discrete units. If the individual particles can be distinguished into separate units, then the system is said to form a discrete system. And if the individual particles cannot be separated into separate units, then they are said to form a continuous system. And for continuous system of particles, we may define a quantity known as density. Now, for continuous system, what do we mean by volume density? When we say volume density, we mean if within a small volume, within the continuous system, a small volume delta tau corresponds to a mass of delta m. If a small unit of volume delta tau has mass delta m, then the corresponding volume density sigma is given by this relation. where limit delta tau tends to 0 shows that the volume is infinitesimally small. So this is the definition of volume density. Now, similarly, if we consider volume mass delta m within area delta A and find limit delta A tends to 0 delta m by delta A, then we may define the corresponding surface density. Like we have volume density, we can describe surface density if we consider the mass enclosed in a surface, infinitesimally small surface area delta A. This density is said to be a uniform density if the density is constant throughout the continuous system. If sigma is a constant throughout the continuous system, then we say that the density is a uniform density. Next, we go on to study rigid and elastic bodies. Now, what are elastic bodies? Elastic bodies are bodies such that if we apply some distorting force on the body, then the interparticle distance in between the particles that constitute the system, that changes. So if we apply some distorting force on an elastic system, then the interparticle distance in between the constituting particles of the system, they change, and as a result the body gets deformed. So here we have a picture of elastic bodies where we see if the two elastic bodies are undergoing a collision, then due to this, the resulting deforming force, the bodies over here we see are getting distorted due to the corresponding deforming force. And the microscopic reason behind this distortion is the interparticle distance between particles that constitute the body, that is changing. Next, we look into what we mean by a rigid body. A body is said to be a rigid body if external deforming force acting on the body is unable to deform the body. And the microscopic reason behind this body not getting deformed even under external deforming forces is that the distance between particles constituting the body does not change with application of force. The distance in between particles making up the body, making up the system, does not change upon application of force. So here you see an example of rigid body, say a brick. No matter whether you are applying compressive force or elongating force, the body is not getting deformed because the interparticle distance between particles making up the body is not changing with this compressive or elongating force. That's all for today. Thank you.